In chapter 10, we're looking at trigonometry, and we're going to start with a few definitions. So far, we know sine, cos and tan because of their definition with right angled triangles, and the sine is the opposite of a hypotenuse and so on. But we're going to think now about a way of defining them sort of more neatly and also outside of 0 to 90 degrees. So we know what the sine graph looks like, but we've not actually had the definition of sine, which will make sense of having the sine of something like 100 degrees. Anything that's bigger than 90 degrees kind of creates a problem for us, because we can't do opposite over hypotenuse if we've got an angle bigger than 90 degrees, because it can't be an angle in a right angle triangle, can it? So this is how we're going to deal with it. Let's imagine we have a circle with a radius of 1. Okay, so the radius of the circle is 1, and this is the x-axis and this is the y-axis. And what I'm going to do is I'm going to rotate that circle, starting with the positive x-axis and going anti-clockwise, and we're going to rotate this way. So if you look at that, this is the x-coordinate and this is the y-coordinate. And if I draw a graph of the y-coordinate, I'm going to put theta on the x-axis and I'm going to put the y-coordinate on the y-axis. So the y-coordinate, when theta is 0, then the radius is a flat horizontal line there, so it's going to start at 0. As I rotate around, the y-coordinate gets bigger until it eventually ends up, when theta is 90 degrees, then the y-coordinate of this radius has ended up at 1. And then when we get to 180 degrees, the y-coordinate is back to 0 again. And so we get this shape. When we go beyond 180 degrees up to 270, the y-coordinate becomes negative and comes down to -1. And then you can see we get our shape of our sine curve. So the y-coordinate plotted against theta, as I rotate theta from 0 to 360 degrees, that is going to be sine. So y equals sine theta. Okay? And now we can also make sense of theta being beyond 360 degrees, because if I keep rotating in the anti-clockwise direction, then I'm going to get the same thing again. The y-coordinate is going to go through the same pattern. And I get negative values of theta by just starting at the x-axis and rotating, not anti-clockwise, but clockwise, rotating this way, and the pattern repeats itself. So there's our definition of sine. And if you think about it, between 0 and 90 degrees, y divided by 1 is going to be the sine. And remember, this is only unit length 1. It doesn't matter if I changed it into unit length 5, then y would be 5 times as big as it was before. So this divided by this, remember it's called the sine theta is a trigonometric ratio. It's the ratio between this side here and this side here. This is only length 1. In the units that we're measuring, this is 1 unit long. If I change the units, I don't change the ratio between this side and this side. Okay? So sine theta is still opposite divided by hypotenuse, y divided by 1 in this case. So that's sine theta. Cos theta is the same thing, but we're just going to look at the x-axis. So the x-coordinate is going to go on this axis here, and theta is going to go here. So I know we normally have y on the vertical axis, but this x here is the same as this x here, all right? And then I can obviously relabel it later on as a y to get y equals cos theta. So in this graph, I'm actually going to draw x equals cos theta, and x is now on the vertical axis. But you see the same sort of idea. When theta is 0, x is 1. And then it reduces its all by 90 degrees, the x-coordinate has gone to 0. As we keep rotating around, the x-coordinate goes down to -1. Then when the line is rotated all the way down to here, the x-coordinate is 0 again. And so we end up with our familiar shape of our cos graph. I've made a bit of a mess of that. I was trying to draw it so it would sync up. There we go. With the one above. So 270 degrees is on 0, 360 degrees is on 1, and so on. They've drawn that in the book this way around, so you can sort of see the the horizontal axis here is the same as the horizontal axis here, and as theta increases, and then if we just take that and rotate it around, we get the graph that we had before. And then our definition of tan in this way of thinking about it is y divided by x, so the gradient of the line, if you like. And the gradient of the line, well, if you think about it, the gradient of the line starts at 0, gets bigger and bigger and bigger and bigger and bigger. We can't have a gradient when at 90 degrees because that's a vertical line. There's no sort of definition of the gradient there, so that's where we get the asymptote, and then and so on. We get a negative gradient which gets smaller and smaller and smaller down to 0, and then from 0 the negative gradient gets more and more and more negative down to minus infinity, or a vertical line again, and so on. So that's where we get our sine, cos and tan and our definitions from. And we also, well, we have this diagram. If you look at this by Pythagoras' theorem, x squared plus y squared equals 1, so that's sine squared plus cos squared equals 1, and tan theta equals y divided by x, which is sine divided by cos. So we'll see that when we get to section 10.3, I think it is. Okay, I'm going to pause there, and then we'll look at how we do the questions in exercise 10a in a different video.